Thermohaline circulation, an internal forcing factor of climate change on Earth. Our planet's oceans are constantly circulating in regular patterns, otherwise known as currents. Currents are driven by a few factors, including differences in solar energy between poles and the equator, ocean floor topography, seawater density, atmospheric winds, and the rotation of Earth on its axis. Thermohaline circulation is a major global current driven by the temperature and salinity of water. It's often referred to as the global conveyor belt, considering it's vital for life as we know it on Earth, through the cycling of nutrients and carbon dioxide around the world. Nutrients and carbon dioxide are consumed in the warm surface layers, which eventually cool and circulate into the deep, where they are enriched once again and will feed the surface layers as they warm. The circulation of these nutrients provides a base for the world's food chain. A good place to begin analyzing thermohaline circulation is with the Gulf Stream current, something that those of us on the East Coast are likely familiar with. The Caribbean waters around the equator are warmed through solar radiation as they flow northward. The circulation seen around the Gulf of Mexico greatly warms the Gulf Stream waters that head north and across the Atlantic to Great Britain and Greenland, where it cools and becomes increasingly saline as the water evaporates and icebergs form. These processes combined increase the density of water, causing it to sink, forming a cold water current at the bottom. The cold bottom current in the North Atlantic circulates back down the Atlantic towards the cold depths of Antarctica. Some of this water curls up the eastern coast of Africa towards the Indian Ocean, where it is warmed and recirculated back around the southern tip of Africa and back up to the Caribbean, becoming the Gulf Stream again. The rest of the water that did not circulate to the Indian Ocean makes its way to the Pacific. It's circulated clockwise as it warms and crosses back across Indonesia and meets up with the Gulf Stream water once again. The water within the global conveyor belt moves relatively slowly, often just a few centimeters per second. For reference, wind and tidal currents generally travel around 10 to 100 centimeters per second. It's estimated that a parcel of water would take about 1,000 years to complete a full circulation through the conveyor belt. Changes in the albedo of polar regions from snow or ice melts that reveal bare ground and increase the solar radiation absorbed have caused a 1 to 2 degree centigrade increase per decade over the past 30 years. The warming trends of the poles diminish the amount of freshwater captured in the Arctic sea ice and has added to the volume of freshwater from rivers that flow into the Arctic Ocean. These processes result in feedback from the global conveyor belt by decreasing the salinity and therefore density of the waters in the North Atlantic, slowing the rate of circulation and therefore nutrients.